hi! I didn't see you there because I can't see you at all. Hey, welcome to my video. Oh yeah, I almost forgot. I might not even be Cugsley. Hey guys, it's Cugsley. Welcome to my video. There we go. I'm recording this because I recently finished a system. I uploaded a video showing how it worked to YouTube, and then I found out that my mic was glitched out and it wasn't actually recording anything, so I'm trying again. So, welcome to my video. Um, I'm going to be showing you a logic contraption that I made over the past week. Spent probably around cumulatively like 48 hours on it, an unhealthy amount of time on it, given the short span that I've been working on. This is a logic system that I've developed for the game Isolation in Dreams, and I want to show it to you today. So, first things first, allow me to give you a demonstration on what it does. Then I'll show you the capabilities, I'll show you the limitations, and I'll show you how it currently functions and why those limitations are there, or why the flaws that are built in there are there. So, what we have here is a little test level. It's just a blank box, and over here you have four things. You have three little bottles of gasoline or lighter fluid on the ground, and then you have a valve here that you can pull. Now, X, just so you know, is the interact button. So if you want to pick something up, or if you want to, pull a valve, you would press X. Now, noticeably, when I press X, nothing's happening, right? R1 is to turn on the lighter. Noticeably, pressing R1 does nothing. Right now, no buttons on the controller do anything, except for the pause button. That works. Now, to give you a preface as to, like, before I show you kind of what I've done, there are a few things on Dreams that are pretty cool, but also rather limiting. One of them is how controls work in Dreams, right? Let's go to a previous version, back from 2024, of the main menu to show you what I mean. So, in a lot of games, you have your control system, and it says, like, hey, here are the controls to play the game. I mean, you can throw item with R2, strike your lighter with R1, hold if you have to refuel, drop item, jump, interact, stuff like that. And you can control kind of what your character does by pressing buttons. Now, in smaller games, that's okay, right? In smaller games, you have your set of controls, and that's it. That's how it works. However, in games that have more controls than your average, or in games where there's just a lot to manage in general, or longer games where you're playing with those controls for a longer time and you want to make sure you're used to them and customized to them, you have the option to change them, right? Now, the thing is, most games on Dreams don't allow that because of the way that Dreams runs its systems. So right here you have your stuff, you press X to continue, it goes to the thing, right? Okay, so let me give you a little kind of showcase here. In Dreams, which is a visual scripting platform where you have your 3D objects you can work with and make your environments, make your character models, do all that stuff. For your programming, you can place down microchips, and these are kind of like your blueprints or your template to be able to place down whatever you want and work with it. Let's just make it things a little bit better to see, right? So, just a quick introductory for those who may not be 100% familiar. Like, if I want to have an if-and statement, like if this and this equals, then execute this, right? You'd put down an and gate. And so you'd have a visual representation of an if statement that has an and conditional. So, I mean, like, if this counter is on, so counter full, connect to input A, and this timer is complete. We're going to open up this timer, and we're going to say timer finished. Then let's get a switch. Activate this switch. So the timer turns on. Once it finishes and goes to full, it outputs a signal. But the conditional is not met because, simply put, we have one half of the AND statement complete, but the other half is not because this counter's off. You turn that on, boom, switch turns on. And it's kind of like your logic stuff. So you can have entire microchips full of logic. I mean, I'll show you a little preview of what I'm going to kind of get into here, which is this entire system here. I mean, you have a bunch of different little logic bits that all work together. Some more organized than others, some less organized. I, in particular, tend to be a little more on the less organized side, but I try my best. So this is how visual scripting works, right? You have the physical visual representations of lines of code. Like a timer is a literal timer, right? And it has different built outputs that you can manage. So you can only really you can't add any outputs of your own. You only have the ones that you have here. Counters, right? Which are basically just like variables that aren't persistent. You can just place those down, right? You also have literal just variables, so you can assign values, numerical values, to a variable, and it will save that, and you can then reference it later in different areas, right? So visual scripting. Well, there is one thing in particular that's extremely important to games, which naturally is your controller sensor, or basically anything that's able to, see what the user is typing. I think in Java it's like scanner. It's been a while since I've programmed in an actual language. I'm very beginner, but I know it's just some little basics. But basically, you have your input chip, right? And so, like when I press R2, which you can see is up here, the R2 button, you see it goes up and down, L2, up and down. I can move them around by pressing down the buttons. If I press down R1 or L1, you see that they turn on, X, circle, square, triangle, right? Also, square opens up this here, but this is just in creative mode. When you're playing the game, this doesn't pop up every time you press square. This is just for creative, right? And same thing with every other button. So you have up, down, right, left does the undo button in creative, but again, that's just in creative mode. And you have all these different things here. You even have like a pre-built enter and back button, which is the colloquial X and circle. But you don't really use those very often. It's not really needed necessarily. It's kind of odd to have those in, actually. So you have your inputs here. Now, what you would usually see in a lot of games, therefore, is something like this. Let's say that, and I'm just going to make a switch, and I'm going to label it jump for now. All right, we're just going to do that for simplicity. I'm not going to get an actual puppet in. All right, so you have your jump option. Every time the user presses X, you wire that X output to jump. So every time the user presses X, the output lights up, and it activates what it's connecting to, in this case, jump. You'd actually have like an animation and, I don't know, something else to coincide with it, like a player is jumping signal to make sure the other things know that your player is jumping, whatever it is, right? Basically, you have like your function. So X activates the jump function, right? If you wanted to have like a crouch function and make that circle, then you would, again, I'm just getting switches for now, but you would have an actual microchip here with all the logic, animation, hitbox adjustments, all that stuff. I'm not going to make all that for a quick video, so I'm just going to use switches, right? If you press circle, well, then crouch turns on. Jump, X turns on, right? You could do both right now, but you would preferably not allow that to happen in a game. And this comes with a problem, and this comes with pros and cons. Pros, right, is that, well, it's pretty easy to work with. If you want to wire up and make your own controls, you just program them in. The cons, though, is that they're not customizable. Like, I can change this right now. I can rewire this however I want. And there we go. Now, jump is circle and crouch is X. Ta-da! But as a player, you can't do that. When I'm in the game, assuming there were a character here, and I pressed circle and jumped, I'm like, well, maybe I want to jump with X. Maybe I want to jump with square. You can't change it. So what I did was I came up with a way to solve that. Now, since there's no key binding kind of like adjustment that you can do in Dreams, right? Since these here buttons don't have an inherent value that the computer can read and then assign to whatever you want to, you have to get a bit creative with it. So I behold to you the, as far as I'm aware, first example of a fully customizable controls option in Dreams as it is here. So when you're in this test level, you press buttons, nothing happens. Let's go into our menu. I use the touchpad for the menu, and you can see circle to unpause, X to open controls, triangle quit. These are baked in. You can't change these, right? So no matter what you set your controls to, the menu will always work. X. So now we are in our control settings. And you see here there is a list of controls you can do. The UI is, it's all right. There's not much going on here, to be fair. It's pretty bare bones. And so you have your list of controls, ladder up, so all these here. And then you also have default controls and reset controls if you want to change something. So let's do this. I'm going to set pickup item to square. I'm going to set drop item to L2, and I'm going to set jump to triangle. Now let's begin. So now, if I go to an item here, if I press X, nothing happens. Circle, nothing happens. Square, I pick up. L2, I drop it. Triangle, I jump. Right? If I go back in here now, and I'm like, I don't want to do this, let's actually do default controls. Then now, X is pick up. Circle is jump. And triangle is drop it. And then, I don't know, if you want to throw it, that's R2. There we go. Then let's go back in these controls here. Let's reset them. And I'm going to set my own custom controls now. I want triangle to be pick up. I want up button to be inspect item. I want the down button to be drop item. Throw, I want to keep it as R2. Run, I want it to be L3. Jump, I'll make X. Crouch will be circle. Dissociate will be the left button. Lean will be the right button. And lighter will be R1. Alrighty. So now when I press circle, I crouch. When I double tap circle, I crawl. Point is that, what was it, triangle to interact? Okay, triangle to interact and then down button to drop. So as you can see here, you can change your controls to whatever you want. So you can set them like this, the game will remember them, and it will keep them like that. And then if you want to reset controls, you can do so. Set them to default, you can do that. The only limitations that there are right now is that, one, you cannot individually delete controls. This isn't because of a limitation in what I'm able to program. It's mainly just because of gameplay space. For those of you who work in Dreams, you know how difficult it is to be able to maintain gameplay. So, work with all your assets as well as your character abilities and not go overboard on the gameplay. So that's the main reason I haven't added that ability. And yet, because I'm really trying to keep this thing as bare bones as possible for the sake of being able to fit it into every scene. And then the other issue, same exact thing. I can fix it. The only problem is it would be too expensive to do so. Is currently there is no limiter on this. What I mean is interact is X. I'm going to set it to X again. I'm going to set it to X again. Well, now it's not X anymore. I'm going to set it to X again. I'm going to set it to X one more time. Well, now every single button is the interact button. To give you an idea as to, wait, one more time. There we go. To give you an idea for why that is, let's see here. Actually, did I by accident fix it? Hold on a moment. Because it's supposed to cause like an overflow where literally every button is the interact button. Oh. Well, shiver me timbers. I think I unintentionally fixed the issue. All right. Well, it still happens where you see here where there's a visual issue with the I guess menu. Where basically you know what? I'll explain this and how it works, because explaining it now would be a bit of a waste of breath. But basically, two issues. I don't have a limiter, so you can set the same thing to the same button multiple times and cause an overflow. And you can't individually delete and reassign settings for right now, both of which are fixable, but just not scalable to have in a live gameplay scene. And for a quick little reference here, this is the gameplay thermometer. Every single object, every single platform, every single interactable item, every single individual microchip, every single wire that connects one thing to another thing, every single tag, every single AND gate, every single counter, every single teleporter, NOT gate, all the wires that connect between them count as objects. And so in here, there's like, 30 objects like in this entire asset here between the label, this piece, the microchip, the cord, or the wires, the items themselves, like the logic bits themselves. There's like 30 items, right? 30 objects making this up. And there is a limit to how many objects you can have in a scene. So if you're making a game on Dreams, where you're obviously going to have assets, you're going to have buildings, the ground, enemies, other visual stuff, lighting, right? Windows, I don't know, whatever it might be. That's all counting towards the objects, which would be technically just things. Wires and animations is a different issue that's calculated separately along as objects, but this one's usually less of an issue later on in the game when you start making more things. So heads up on thermometer. So, biggest thing. How did I make this system? How does it work? Allow me to show you. There are two components in this system. There is the actual menu microchip, and this menu microchip basically just makes it so that way you're able to actually tell the game, hey, this is what I want to be active, this is what I want to do. By the way, I'm kind of curious now. If I were to, I don't know, set one thing, it should cause an overflow, right? 1 million, now it's 2 million, now it's 3 million, now it's 4 million, now it's 4,444,444, which should technically equal every button. So I have to check the player model to find out why it doesn't have a multiple compatibility. So, basically, here we go. How it works is in order for you, and I'll actually go into the player first. In order for you to be able to customize your controls, you first need to disconnect the wires coming from your sensor to the actual functions that you're trying to activate, which you can see right here, right? Over here, we have our functions. Inspect item, drop, throw, jump/ascend, position toggle, dissociate, lean, lighter toggle, speed button, interact, and this is just something else, right? So you have all of your wireless transmitters that then actually communicate with the things they're trying to do. Like, for example, the position toggle, this one right here, actually communicates over to this microchip. So this is all of the logic that goes into being able to prone and crawl, right, or crouch and crawl, right? But I'm not going to keep that open the entire time, so I'll just show you these little boxes here. A lot simpler to look at. So first, you need to disconnect your inputs from the actual things you're trying to do. And the reason you want to disconnect them is because you don't want to be in a situation where you're having to hardwire your inputs to your functions, because then you can't customize them. So first, you separate them. Now what you have to do is you have to be able to create a system where you are able to tell what button the player is pressing, right? That sounds easy. You have a whole microchip that does it. But the issue is that your functions, they can't tell without having a connection, right? So you would think, oh, well, if I want to be able to tell what the player is pressing, I'll just wire it too. But then we have that same issue. Well, now you have a direct connection that can't be changed. So we have to create a system where your functions know what button you're pressing without connecting directly to the controller sensor. Now, one thing you could do is you could get what's called a wireless transmitter and a wireless receiver, all right? I mean, that seems pretty self-explanatory. What you do is you say, hey, when the user presses X, we'll label this as just X, and when this receiver senses X, look at that. Now I can put this way over here. I can put this as far away as I want, within the range of the zone. Let's make that site-wide. Whenever I press X, this turns on. Issue, though. That doesn't give a concrete value or a concrete measurement of what the player is pressing, right? That's basically saying, hey, I'm assigning a name called X to activate when X is pressed. But how does the computer know what that means? Not really, right? It's still kind of up in the air. So I worked with math. What I did was this. I took every single button the player can press within reason, right? The only ones I left out were the touchpad and the left and right stick movement. R3 and L3 work, but movement, they stay the same. They don't change. So every single button that you can press is wired into this system. Why are they all tangled? I don't know. It's just how Dreams does it. But I have them organized in here. So what you see here are a bunch of chips with numerical values on them, right? And I've even labeled all of them too. Directional pad down, directional pad left, up, right, L1, L2, L3. So this is your left side of your controller basically, and then you have your right side X, square, triangle, circle, R1, R2, R3. So here's what I did. First things first. I made it to where every time you press a button, we'll use X as an example. Every time you press X, that input powers on this little number transmitter. We'll just call it I think it's like a value slider. We'll just call it a value setter or a setter. Every time you press X, it activates the setter. right? And this setter has a value of 1 million, or in other words, to make it simpler, a seventh digit 1, right? The reason I say it like that is you'll see why, right? However, it's easier for you to visualize it. 1 million or seventh number, or seventh digit is 1, right? It turns this on. It transmits that signal when it's turned on to this calculator here, which is adds everything together, and it compresses it into a single number. So what you actually end up seeing, this is make this real big, is this. So when I press X, 1 million. Now let's say I press square, well, that's 100,000, right? If I press X and square, you see it adds them together, 1,100,000. If I press all these together, now it's 1,100,011. If I press all these, 1,111,111 if I press every single button on the right side, right? So it's kind of like binary, actually. Oh, my controller's moving. It's a gyro. So as you can see here, you have 1, 1, 1, 1, 1, 1, 1, right? So you have your, see when I let go, it goes away. Watch this. Just put that in there. And then, whoop. There we go. So you have your, if I hover over it, it goes away. But you have your first digit, second digit, third digit, fourth, fifth, sixth, and seventh, right? Binary code. Until we get funny with it with threes, but don't worry about that. So what you have here is all of your inputs being combined into a single value. And you have your left side too. So you could do some really weird stuff. Like, for example, you could do X is 1 million, down button is 3 million. So when you press both at the same time, you end up with 4 million, right? Or a seventh digit 4, right? It combines everything into a single value. That's how I separated your inputs from your executables. Now, what do we do with this information? We have successfully created a system where I can store all of what the player presses into a single variable that has a distinct numerical value per button that does not change, no matter what scene you're in, no matter what you're doing. What do we do with it? Well, over here, we have our input customization. It's not the best name for it. It's kind of more like our executable file. This is where we actually make it do things, right? We have a few distinct chips here. We have our input routers. We have our, okay, this says deactivate during anim. This is more like a activation hierarchy, but you have your input routers, you have your kind of like calls on the functions. It's like, hey, activate this function, activate this one, whatever one is active. We have our input decode, and we have our variable like retrievals. What these are, I'll explain when we get to the menu. Basically, what they do is they find out what value the player set that function to, and it compares what the player presses. So, for example, input, not input, but like interact with items or pick up items, if you remember correctly, right, was X. There we go. It's X, right? So what that means is interact is set to 1 million. So what happens is it takes whatever interact is set to. Let's actually do a default controls so we can have an honest to God example. Now everything has a value to it. So interact is equal to 1 million. So it takes the value of 1 million, right? It divides it by a million to get a value of 1, which rounds down to 1, and it transmits that outwards, right? It says, hey, everything else is turned off, but this here, this seventh digit is correct because this is a decoder. This is able to split your 7-digit number into 7 distinct values. So you have your ones place, your tens, your hundreds, thousands, 10,000s, 100,000s, and millions, all isolated into singular digits. What that looks like, therefore, will be something like this. Let me turn all of these on. I did something very funny. Now you see all of these are turned on here, right? What you end up seeing is this here. Let me just kind of give this a maximum value of 4. 2, 3, 4, 5, 6, 7, right? That's your 7 digits. So if you notice here, all of these are actually set to 4 because I maxed out the values, but it's able to isolate every single digit into its own number. To give you a better example, if I were to input, right? If I were to give this decoder an input of 1,237, no, 1,234,567, right? Oh, shit. The maximum value is 4. That's not going to work. Let's make the maximum value way higher. 1, 2, 3, 4, 5, 6, 7, right? It can decode this number into, well, 1, 2, 3, 4, 4, 4, 4. Huh. Shit, is there something wrong with my decoder here? That's actually not good. 7. Oh, fuck! This is maxed out to 4. That's not going to work. Let's just make that higher. There we go. If you have the thing set to a maximum value of 4, it'll never go past 4. So you have 1, 2, 3, 4, 5, 6, 7, right? You see that it isolates every single digit. This means that you can take the value that you set to a particular function, and you can find out, well, what button did they press, and what does it equal in simplistic terms, right? One's value. And then we find it. So what this does, let's set our stuff to an actual default, so that way we can go based off how it actually works in the game. Jump is x, or jump is 1 million, which happens to equal x, right? And so it emits a value of 1. All these are 0 because it's 1, 0, 0, 0, 0, 0, 0, 0. Now you can have multiple buttons to the same function. It's not common, but you can, right? And this accounts for it. So it says, hey, this is active. Let's calculate it. All right, well, there are two conditions. If the player, because remember, we kind of combine every button the player presses into a single value, and then we decompress it, right? Because this is able to go across scenes, and then this is able to decompress it or unzip it and actually use those values. So let's decode it, and then let's combine our stuff into kind of like a single wire, and it just makes it easier to manage so we can split it up later, right? It makes everything look a lot neater. This is technically not efficient, but it works. Visually, it's nicer. Okay. So whenever I press X, you see A lights up. If I press triangle, C lights up. Square, B lights up. Circle, D lights up, right? Basically, it's your different digits, right? That's what that is. So every time I press X, though, A lights up. That's because that's the 7th digit. It's way up here, going into A, going out of A. And it says, okay, well, is A equal to what this value is, right? What jump was set to. If yes, activate the jump function. Let's do it, right? It's this right here, this wire. So you'll see that activates. Or is the difference between A and input an equivalent of 4? Oh, no, sorry, not difference. Is the big number when comparing A and when comparing input and setting 4? This is a tricky one. What this means is, does the player either simultaneously press 2 of the same caliber button that's associated with whatever this is set to, or is this set to both buttons? Because remember how I mentioned kind of in passing how you can press 2 buttons at the same time and end up with an addition of 1 and 3 to equal 4? That's what that means. You can press both buttons at the same time. And it just so happens, if you're noticing here, both are equal to the millions, which means they're both 7th digit, right? And that's what this calculates. You can have 2 values stored into a singular digit, right? If it's 1, it's the right side. If it's 3, it's the left side. If it's 4, it's both sides. So what I'm saying here is, remember, if this has a value, that means that 7th digit is assigned to a value, right? Whether it's X or down button, we don't know. What we do is we decode it. So we say, well, if this is assigned to the 7th digit, right, and you press both 7th digit buttons, well, then one of them's correct, right? And what we end up saying is, hey, emit. There you go. Or if what this is set to is both options, right? If X here is assigned to both 7th digit options, then it doesn't matter what you press, because this is equal to 4, the big number is 4 here, and then this is 0, so that goes through. That's how that works. And frankly, I'm noticing now I should probably power this to the input. I think the reason why it wasn't working in demonstration when I set every single button to interact was because this is always emitting and this kind of causes an issue. So we'll get to that. But that's something different. I'll fix that in the back end. That's just a little bit of a processing issue, right? But you get the idea. So what we end up having here is we basically say, hey, what is the player pressing? What is the actual setting assigned to? Like what button do we assign it to? And we do compare those two values to find out if they're compatible, right? If they're equivalent, that means the player pressed it. If one of the values equals 4, that means that either both buttons were correct or both buttons were pressed, in which case activate it. That is how my system works. At least that's how the player side of things work. The menu side is actually a lot simpler, because what the menu does is it kind of does this, but in a more roundabout way. What it does is it mixes together this system here with a menu screen, right? So like when you're in your menu, I of course created the UI that prints out every single list of items, right? So you have interact, your inspect, your drop, your throw, your run. Those are just text gadgets. And I gave the ability to the player to go up and down on that. And basically what I do here is I'm not going to show you the logic of it because it's kind of just not necessary. You can make a menu however you want, so it's not necessary for you to make it like this for the system to work. You just need to know that you need to encode values to variables. I select, I don't know, jump. So I say, hey, I want to write a value to the jump variable. So I'll select it. Now it's glowing. What value do I want to assign to jump? I want to assign circle to jump. Let's go out of that now. What that means, so if we actually go in here, you'll see over here, you'll see that the jump variable now has a value assigned to it, which is 1000. And so that's where you end up seeing the correlation between the menu and your executable. So now, hey, look at that. That's turned on. That's saying, hey, I have a value. It's 1000 as it happens, right? And it transmits it. So basically all I'm doing here, there's a little bit going on to it. This is all the UI stuff. We can ignore this. That's just to make it so that way it looks pretty. This is the actual stuff. Basically what I say is, hey, there's a bunch of different variable modifiers in here setting variables to different things. And you can see here there's a value slider that will turn on. Let me show you kind of the graphics of this, because while we're at it, right? Let's just delete this backdrop here. And let's just turn this on by default, right? There you go. So like when I press X, you see I kind of flickered a little bit over there. Keep an eye on this right here, right? Watch it flicker. Watch, I'm gonna press X. See how it flickers? What happens is whenever I press X, wherever I press a button, it changes to the value of the button I'm pressing. Pardon me a moment. Alrighty, so this here will assign itself to the value that you're pressing, your button, and then it'll write that to whichever variable selected. So like when you're in that menu and you're going up and down, notice how this here is going along that, like along the timeline. That's how I'm able to select the variables and say, hey, write circle 1000 to jump, and then it moves on to the next variable. So that's just menu stuff. It's not super important. The idea is that if you want the system to work, if you want to be able to tell the computer, hey, this is what the player is pressing, here's what they're supposed to press to activate, then you want to be able to basically say, hey, I want to assign every single function a value. And then it's able to look for that value. So a little bit of a bloated video, but it was fun to explain it. That's how it works. I will fix one of the glitches that I have here live, just so you can kind of see what I mean by I had an issue with it. What I should do is this. Notice how this differential of 4 is activated by the activation of this here. What that looks like is this. So let's set everything to X. Okay, so here's something funny. This is always on. I am always interacting with an item, which isn't very useful because it's basically saying, hey, I can't pick up something because I'm currently already trying to pick it up. That's not good. What we need to do is this. I need to basically say, hey, now question, can I do this? There's two options. I can directly connect this to the input that it gives. The only issue is that if I make this value equal 4 and this isn't turned on, then it'll still execute jump. So what this means, therefore, and it kind of sucks too because I was really proud of the system for optimizing it, but I think I optimized it a little too heavily to the point where it's not actually useful, is I need to add an AND gate. Now, I could add an AND gate. I'm going to do a node because I feel like it. Basically, I need to say, hey, if this is turned on and A is selected, this is kind of like a dumb version of an AND gate. What it does is this node will pass the A signal through and go straight to turn this on, but this here node won't pass it through unless this is active. That's all it does. That's it. Simple as that. In which case, now I have two things that are going through here. I might just be better off putting it into a microchip of its own and doing it like that. Because at least then when I put it in here, I can then activate the microchip on its... shit, that's not what I didn't want to connect it to this. No. I can then just activate the entire microchip as a whole. That might actually prove a little bit better. So now, right, when I process it, let's actually assign it like this. Here's an example. A and down button. Notice now how this isn't... Actually, no, this is turning on. It's doing it again. I see. I need to make it to where this only turns on when you press it. There we go. That is the only way to make this work. So now, that's better. That's how I fix it. I was trying to avoid doing it like this, just because, again, I'm using more wires as we've established. All of these wires count as an object, and frankly, I'm only making it worse by adding this in. But at the same time, you kind of want your program to function, right? So you sacrifice what you have to. Either way, I'm going to fix the rest of this off camera because there are a lot of microchips that I have to do that for. So you actually, hey, well, we found a little issue on film. Either way, that's it. That's how the system works. What you end up seeing as a result is our little test thing here, where you can set your controls to whatever you want, and they all work as according to plan, except for being able to have dual controls. I guess the last thing I'll mention is that there are two things that you can do with the system that isn't typical, but it's appreciated, I think. You can either, check this out, because of the way the system works, in that it goes as a function per function setting, you can set every single function to the same button, like so, or you can set every single button to the same function. Right now I'm cheating by overflowing. I will really quickly go into, I guess, how that works, since that's something that you might want to know about when programming something like this. Because of the way Dreams works in its system, yeah, we'll go in here. You can overflow your values. What that means here, right, is this. Basically, when I assign a value to a function, right, via that menu, I deleted the backdrop so that way you can actually see everything clearly as it's working, right? When you assign, interact to X, right, and you assign it 1 million, you're not setting it to 1 million, you're adding 1 million to this variable, which means if you go back in here and you do it again, now it's 2 million. If you go back and do it again, now it's 3 million. If you go back and do it again, now it's 4 million. If you go back and do it again, now it's 4, right? Actually, fun fact, that's why when you press X, it goes to X. When you press it again, it stays as X. When you press it a third time, it actually changes to the down button. Because remember, down is your 7th digit third, so that's the symbol for 3 million. And when we press it again, it stays that way. And we press it again, now it's technically everything. So if I actually go in here and go into here, everything is active. In fact, if I were to get rid of the backdrop on it, because if you notice, they have little black squares behind them to make things simple. It actually looks like this. So it looks like all of the buttons pressed together. So it's a little bit easier to see now, right? It's not, yeah, I could make it to where it lines them up for you, but that would take an absurd amount of processing on Dreams, and I don't feel like doing that. So basically, what can happen is, well, if I were to set it to this and square and circle and R2, that's working as it should. But you got to be careful. One thing I mentioned was I haven't added a limiter in. What you should want to do in a system like this, and the only reason I haven't is because you're able to change your controls mid-game in whatever scene you're in, which means that this has to be scalable to work in every single scene in the game. And to do that, I need to keep its gameplay down. But if this were just in the main menu, I would definitely add in a limiter. Basically, what a limiter would do is say, hey, this is already worth 1 million, exactly 1 million. The seventh digit 1 is equal to 1, right? Therefore, do not add in another 1. If I press X again, do not add it to 2. But it does right now because I haven't added in a limiter. Hey, it equals 3, you can add 1 because it doesn't equal 3, and it doesn't equal 4, you cannot add 3 to it. But I just did, right? So that's what a limiter would do, is stop it from overflowing. Because you can do some really weird stuff. Like, for example, I will set this to R2. I will set this to R2 again. I will set this to R2 again, and I will keep doing it. Oh, shit. Wrong one. Oh, don't go down there. Okay. It auto goes down to the next selection. R2, R2, R2. See how it keeps going up by 10? Eventually, it's going to go up to 100. And it set itself to R1 because 100 is R1. So essentially, you overflowed your value, right, on your variable to the next digit, which ends up setting it to a completely different button. So now if I press R2 to interact with something, it's not going to do anything because it thinks it's R1. For that, you would have a limiter to stop that kind of stuff from happening, but you'd have to do that per variable that you're handling here. So it's a little excessive, but that's how that would work. Either way, that's the kind of brunt of it. I mean, I guess I could go into how like the menu system works. Like for example, you have your that you can like if you hold down a button, it kind of speeds through the menu like any other game would. That was fun to make. But again, this is kind of less important. This is just more like, hey, how does the menu work? How do I get the UI to do stuff? All that. And it's not as important. So I'm gonna leave it here because I could ramble on this for days, and I'm not sure that you guys want to hear that. So thank you for watching. This is just a little snippet, a little sneak peek into the fact that yes, I am still working on isolation with Cam. Yes, it is coming along. Yes, it is coming along very slowly, but it is getting there. We're almost done with it now. I've been saying that for the past like 2 years, but I really mean it. We've been adding more onto the game every single time. It's fun. We're enjoying working on it, but the fact that I'm starting to work on this and having finished this system here means that we're getting to quality of life updates. So, I mean, there's about, 3 more levels left in the game to work on, after which everything's done. I'll just go through, patch stuff up, make sure everything goes through nicely and works smoothly, and then release it. Available on Dreams, not available on any other platforms, but after which we may be intending on doing a PC port. So that'll take another 5-6 years to do, but it'll be worth it. It'll be fun. All right. Thank you for joining. I will also release a shorter version of this video here on YouTube, unlisted though, later for kind of like Reddit, so I can share like kind of the cool stuff to the Dreams subreddit. Although I will wait until after I have fixed our little character glitch here with their 4 deviation before I upload that, because I want to make sure that I can demonstrate it and work it properly. If I can find a way to fix this without doing painful shit, I will, but I will see. Either way, you guys have a wonderful day. Thank you for watching, and I'll see you in the next video. Or maybe I won't, who knows? I didn't see you at all during this one. You elusive bastards. Alright, bye!